So welcome to the first part of liver physiology. So one of the things we think the most when we think about liver is thinking about metabolism. And there's a definition from a medical dictionary of metabolism here. You can read that yourself in the slides. The next important thing to think about metabolism is there's two types. There's anabolism, that's where you create or build up a substance, and catabolism, where you destroy or break down a substance. And the liver performs both of these functions. Now, some of the major metabolic pathways for proteins, carbohydrates, and lipids will be covered in greater detail either by Dr. Cottrell or by other lecturers. I'm just going to focus on the liver today. So again, in terms of metabolism, setting the picture, what does the liver actually do? Well, in fact, the liver has lots of different functions in terms of metabolism, involved in digestion, energy metabolism, involved in other processes like immunity. It's also involved in detoxification, which is often what we think of when we think of the liver, involved in detoxifying drugs or other exogenous compounds, or compounds from outside the body, and also some compounds produced by the body as well. It is also involved in energy and nutrient storage and production of various components of the blood plasma, particularly the plasma proteins. So in fact, it's a highly metabolically active organ. It's got over 500 recorded functions. And you could consider all functions of the liver to be metabolic processes. So let's give some basic facts about the liver. It does lots of things. And to go with that, it's no surprise that the liver is also the largest organ in the body. It's able to rapidly regenerate, and that process of rapid regeneration is really important in its function because it's often dealing with toxic, damaging compounds. And we'll come more to regeneration later. Now, in order to fulfill its functions, it actually, in a cardiac cycle, takes about 25% of the cardiac output. And I'll cover what cardiac output means in the cardiovascular lectures. But in simple terms, it's the amount of blood pumped around the body in a minute. And it has two blood supplies. We have a blood supply from the hepatic artery. Now, the hepatic artery is what we would consider the main arterial branch from the aorta, which runs all the way through your body. And for most organs, the artery branch from the aorta is the main blood supply. But in the liver, the hepatic artery only supplies about a third to a quarter of the total blood. Most of the blood supply, at a much larger volume, about 1 litre per minute, is from the portal vein. Now, the portal vein is blood that has been enriched with nutrients from the gastrointestinal tract. That blood then passes directly to the liver. And the reason for that is it allows metabolism of products in the liver immediately after they've been absorbed from the gastrointestinal tract. And that brings us to the idea of first pass metabolism. And often drugs that are absorbed from the gastrointestinal tract will also go metabolism via the liver. The other thing that the liver also does is it produces hormones and releases them, which help to enhance blood flow to the liver. And also during digestion, those hormones are released into the blood supply, so that the blood flow to the liver is increased. Now, as with almost all my lectures, what I want you to understand in the function of an organ, you almost always are best to understand the underlying anatomy. So if we first look about where the liver is positioned, you can see the liver is roughly the same level as your stomach on the right hand side of your body. And there's just a little bit more detail. You can see that the liver is accompanied with the gallbladder next to it, and that's important too. You sometimes can see it as part and closely related to the gastrointestinal tract, both in terms of its blood supply, but also because it releases things into the gastrointestinal tract as well. And we'll come back to that later. In terms of the structure of the liver, it's a multilobular organ. There's 8 different lobes, and each lobe independently functions as a liver and can perform all the functions of the liver, but it also serves as a backup because the liver does a lot of toxic metabolic processes, and so if one of these lobes were to be damaged, the other lobes could continue their actions as normal. I also want you to look closely at the portal vein and the hepatic artery. Now, hopefully you can see that the portal vein is much larger than the hepatic artery, and that's because most of the blood supply, as I've already mentioned, is coming from the portal vein into the liver directly from the gastrointestinal tract. So blood is coming directly to the liver from the gastrointestinal tract. Now, blood flows through the liver and then is returned to the main venous system and will leave the hepatic veins and enter into the inferior vena cava, where it will be returned to the circulation and returned to the heart. Now, if we look at the liver in a little bit more detail, each lobe of the liver is made up of lots and lots of smaller units called lobules. And what you can see from these lobules, there's a cartoon of one there, and there is a real life lobule there. You can see that they have this highly organized structure, which is kind of hexagonal, and that's because that hexagonal shape, or predominantly hexagonal shape, gives you the most efficient use of space. The hexagon-like shape gives you an increase in the surface area. Now, in the middle of each of these lobules, you'll see that there's a central vein, and surrounding it there are the hepatocytes, and on the outside, as well as being surrounded by connective tissue, at the corners in between lobules, what you get are what we call the portal triad. Okay, and to give a little bit more detail of the portal triad, this is where we have the hepatic artery, labeled here, the portal vein, which is much larger, and we can also see the bile duct, which is removing products from the liver, and that's Yes, so if we then look in cross section from the lobule and just look at the liver lobule in a little bit more detail and take a cross section through there, we can see that blood will flow in across what we call sinusoids, which are channels through the liver. And you can see the network of sinusoids a little bit better described in this slide here. So the blood is flowing across the sinusoids. These cells that you see in the liver are the hepatocytes. And you can see it's densely packed of hepatocytes. If you look across now to this video, you see there's packed full of hepatocytes there. So lots of cells, lots of surface area, and we have these channels running through creating this surface area. Worth bearing in mind that the hepatocytes will perform the metabolic functions, but they'll also produce bile, and that bile is removed from the liver via the bile ducts. That brings us to bile production, which is one of the major metabolic functions of the liver. And as I've already mentioned, bile is produced by the hepatocytes, and the liver produces around about half a litre to maybe over half a litre or more per day. And this bile is continuously being released into the bile ducts, like so, and the bile ducts can connect with the pancreas directly to the gastrointestinal tract and be mixed with things produced or digestive enzymes produced by the pancreas to go into the gastrointestinal tract. But as the liver is constantly producing bile, we only really need bile during the digestion process. So only really in great amounts when you're actually, for example, just eating a meal. So the bile can be stored in the gallbladder for later use. Now, what is the bile? Why is it important, and what does it contain? Well, it contains what we call bile salts and bile acids, and we'll come to the functions of bile salts and bile acids in a little bit more detail in a moment. What it's important for is fat digestion, but also for excretion of fat and excretion of some other things from the blood, which we'll talk about more in a moment as well, because some things are excreted by the liver into the gastrointestinal tract and then excreted in the feces. So in terms of digestion, what is the role of the bile salts? So I've already mentioned that bile facilitates the absorption and digestion of dietary fats. So when you ingest a meal rich in fats, the fat tends to congregate as large fat globules, okay, as shown here. Now, clearly those large fat globules are going to be not easy to digest. Think of it like, you know, mixing fat with water, just large droplets, not mixing with the aqueous environment of the gastrointestinal tract and also into the blood. So the bile salts have a hydrophobic side and a hydrophilic side. And what they do is they break up these large fat globules into what we call emulsified droplets. So those emulsified droplets can be really quite small. If you think of an emulsified type of thing, think of something like mayonnaise compared to oil floating on water. Okay, so and that smaller emulsified droplets are easier for your body to digest and absorb those fats from your diet. Now, I also mentioned that the liver played a role in excretion, and that's particularly true in the excretion of lipids and also the excretion of cholesterol. Now, cholesterol is synthesized in the liver, and that's by the enzyme called HMG coenzyme A. I'm not going to go through into the name. We'll talk about the role of this enzyme in cholesterol formation in terms of cardiovascular health in a lot of detail in later years. All you really need to know now is that cholesterol is essential in synthesis of both the bile acids and also your cell membranes. And the liver excretes the cholesterol in bile salts in combination with what we call lipoproteins. So these are large kind of complexes formed of both lipids and proteins, hence the name. So the low density lipoprotein, or LDL, essentially carries the cholesterol from the liver out to the tissues, and the high density lipoprotein carries cholesterol back from the liver, back to the liver to either be converted back into bile salts or to be excreted. So the liver, as well as producing cholesterol, regulates the amount of cholesterol that is in your blood as well. So it's really important to realize that the liver is the most important component in regulation of plasma cholesterol, and we'll talk about that in other parts of PM1A, but you'll also learn a heck of a lot more about it later when you get to part 2. The other excretion role of the liver again involves the bile, and that involves things what we call bile pigments. I'll talk about some other substances as well. So we have red blood cells running through our bodies, and red blood cells have a finite lifetime, and when they get broken down or recycled, the byproducts from this produce bilirubin. Now, bilirubin is a potentially toxic pigment that gives bile its colour, and in fact is also ultimately responsible for giving your urine and your feces its colour as well. Now, bilirubin is conjugated in the liver. We'll talk more about conjugation later, and it's excreted in the bile into the small intestine, and also some of it is excreted into the blood and excreted by the kidney, hence the colour of the kidney. So it's really important that it's eliminated by 2 processes, both the feces and the urine, or it can be reabsorbed if the body needs it. Other things such as that are excreted by the liver include iron, so you've got excess iron in your diet, and globin, which is a really important protein in your body. They're recycled via what we call this enterohepatic circulation. That's the excretion into the digestive tract and reabsorption if required. And what's important about this cycling or recycling of this is that some drugs that you'll study later on are also eliminated or recycled by the bile and the gastrointestinal tract. And I'm not going to go into any more detail about them here. And that brings us to bilirubin and jaundice. Now, Jaundice is a disease which is characterized by a buildup of bilirubin in the blood plasma. And because we've already talked about bilirubin being conjugated in the liver and excreted by the liver, what that could mean is that could be an indicator of liver disease. So this just shows the classic yellow pigmentation of tissues characteristic of jaundice. And the yellow color is due to this increase. It's often most notable in the eyes, but it's really important to realize no matter what your shade of skin is, there will be alterations, and it can be observed in terms of the shade of your skin having a sort of yellow tinge or appearance to it, but often most notable in the eyes. And often when the liver fails to conjugate or sequester and then remove bilirubin, then that's what we call hepatic jaundice. Sometimes we also get what we call obstructive jaundice, and that's when the bile is prevented from moving into the blood plasma and being excreted in the urine. And that obstructive jaundice is occurring normally when there's a block in flow in the liver. Jaundice can also occur for other reasons, such as hemolytic or bursting of blood vessels, and that's often an immune type reaction. It's not associated with liver problems.